This video is an introduction to solving word problems, specifically the skill of translating words into math. The example we're going to work with is from the GRE general test, but the skills we're going to learn here are applicable to any word problem on any test. The format of this question is numeric entry, which means there are no multiple choices. Instead, we're supposed to figure out the answer and enter it into this little box, which I'm actually going to move out of the way here to make some space. Now, anytime you solve a word problem, the first thing you need to do is understand what they're telling you and what they're asking for. Let's start with understanding what they're telling us. They say that when the decimal point of a certain positive decimal number is moved 6 places to the right, the resulting number is 9 times the reciprocal of the original number. That's quite a handful, so we need to find some way to break it down. And the trick is to find the equal sign in the text. We're looking for a verb that indicates equality or equivalence, and it's usually going to be the verb to be. So looking through this, I see the verb is, but actually it's part of is moved, so that's not what we're looking for. If we keep going, we see, is right here. This is means equality. It's saying that the quantity before it, which I'm bracketing off in blue, is equal to the quantity after it, which I'm bracketing off in green. So we now know that the given information is that the blue equals the green. The next thing we need to do is translate the blue and the green into mathematical expressions. Let's start with the blue side of the sentence. Here we're talking about the resulting number that you get when you take a certain positive decimal number and move its decimal point 6 places to the right. So let's call the decimal number that we start with x, and then figure out how to represent this moving of the decimal point. Most people know that moving the decimal place has something to do with powers of 10. But if you can't quite remember how that works, don't panic, because you can always make a little sidebar to figure it out. So let's take a simple example. Let's say a number 1.003. Now, if we move this decimal point to the right, the number becomes 10.03. And then if we do it again, it becomes 100.3. And notice what's happened. Each time we did this, the number became 10 times bigger. So it looks like we found a rule. Moving a decimal 1 place to the right is the same as multiplying by 10. Applying this to the blue part of our sentence, the number x gets its decimal point moved 6 places to the right, which means this scooting thing happens 6 times. And according to our rule, that means the number is multiplied by 10 6 times over. In other words, it's multiplied by 10 to the 6th. So let's write x multiplied by 10 to the 6th. And of course, all of this is equal to the green part of our sentence. The green part says 9 times the reciprocal of the original number. So we can write 9 times, and then the original number is just x, so the reciprocal is 1 over x. And with this equation, we've captured all the information given in the problem. In fact, this is what you'd write on your scratch paper as the givens, not this top line, which I just put here as a temporary crutch. As for the question, it's this last sentence. What is the original number? Of course, the original number is x, so for the question we can write x equals question mark. And now all we have to do is solve this equation. Of course, there's a lot of moves you can make in algebra. You can add something to both sides, you can divide both sides by something, and the biggest question students have is, how do you know what to do? Well, the key is to remember what we're trying to achieve. The goal here, the dream equation that we're trying to get to, looks like this. X on one side, not necessarily the left side, and then on the other side, just some number. So what we want to do is corral all the x's to one side, and then corral everything else to the other side of the equal sign. So we have to get x to appear on only one side of the equation. This means we have a decision to make. Do we try to get rid of x from the left side or from the right side? Well, suppose we choose to get rid of x from the left side. That would mean dividing everything by x and getting this. 10 to the 6th equals 9 times 1 over x squared. But this isn't great because what we want ultimately is to have x all by itself, not at the bottom of some fraction. So let's attack the equation from the other direction and try to remove x from the right side. This will involve multiplying everything by x and will give us 10 to the 6th times x squared equals 9. And now we want to get this x term all by itself, which means getting rid of the 10 to the 6th. So let's divide everything by 10 to the 6th and get on the left side x squared, which is going to be equal to 9 over 10 to the 6th. And then the last change we need to make is to transform this x squared into just plain x. And to do that, we take the square root of both sides. Thus, x squared becomes x, and that's equal to the square root of this fraction. To take the square root of a fraction, you can do the square root of the top over the square root of the bottom. So this top is 9, and its square root is 3. And for the square root of 10 to the 6th, all we have to do is cut the exponent in half to get 10 to the 3rd. Why do we cut the exponent in half? Well, if you think about what happens if we take 10 to the 3rd and square it, you end up multiplying the exponents and getting 10 to the power of 3 times 2, which yields 10 to the 6th. And that makes sense because 10 to the 3rd is a triplet of tens, which when you square it means you have 6 tens. And taking the square root is going in the opposite direction, so we end up cutting the exponent in half and getting back to 10 to the 3rd. And now it looks like we're all done because we know the value of x. However, this is a numeric entry problem, and if they wanted your answer as a fraction, they would say, give your answer as a fraction, and instead of providing you with just one box, they would provide you with a combination box that looks like this, with room for a numerator and a denominator. Now, since we don't have one of these fraction boxes, we're going to have to express our answer here as a decimal. Luckily, that's going to be fairly easy, because what we're doing to this 3 is dividing it by a power of 10, which means all we're going to do is move the decimal point. We're still going to have a 3, just the decimal point is going to shift. Now, we saw over here that moving a decimal point to the right is what you do when you're multiplying by 10. Here we're dividing by 10, which is the opposite of multiplying, which means instead of moving to the right, we're going to move the decimal point to the left. And we're dividing by 10 to the 3rd, which means we're going to make 3 moves to the left, and our decimal point ends up here. Now all we have to do is fill in these blank spaces with zeros, and we have our final answer, which we can write up here, 0.003. And now that we're done with this problem, let's quickly hit a couple of takeaways that you can apply to lots of other problems. Our first takeaway is that you should find the verb that means equals. In this problem, as is often the case, the verb is was the equal sign, but sometimes you might have a problem, let's say, about money, in which case costs might be the verb that indicates equality. Or maybe in a geometry problem, you might have a phrase like has the same area as that means equals. Of course, there are some word problems that have more information than this simple one did, so you might have more material than can fit in just one equation, in which case it's probably a good idea to make a table, and a table is just a way to contain more than one relationship. But even when you're making a table, looking for a verb is a really good way to break information down and to understand relationships. All right, moving on to the next tip. If you can't remember a rule, make a sidebar. We did that up here when we were trying to figure out what happens when you move a decimal point, and we did it over here to find a rule about exponents. Of course, you should still try to remember the rules, make flashcards, do all that work, but sometimes on test day, you might forget, and it's great to have this kind of scratch work strategy as a fallback. Speaking of strategies, a great one for you is to watch more videos from Chiron Prep. Thanks for watching this one, and I hope you'll give it a like and subscribe to the channel.